Welcome to the walkthrough for the frequently made mistakes for assignment 2B in my CS 5254 class. First, please make sure you document your code thoroughly. It's not enough just to simply have your code written and rely on my specification comments. You have to document the lines of code themselves. Next, inside the simple semaphore class, don't define a field that keeps track of the total number of permits that you think may be allowed. That's not the way that semaphore semantics are defined in Java, and they're not the way that we define semaphore semantics in our simple semaphore class either. They can grow without bound every time release is called. That's just the way it works. Let's now take a look at the acquire method and some problems there. So make sure that you never ever lock the lock in the try portion of a try finally block, but instead always move it to before the try, as we've discussed in the videos and in class many times. Next, you don't need to have a catch clause that catches the interrupted exception. Just let that exception percolate up the call stack naturally. Also, there's no sense to recall acquire if an exception has occurred. That defeats the purpose of having an interruptible version of acquire. And then finally, don't decrement available permits in the finally block, since that will yield the wrong value if cond_await throws an exception. So moving on, here's some other problems with acquire. There's no need to have a Boolean flag to check to see whether interrupts have occurred. That's not why we have acquire. Acquire is meant to be interrupted, as you can see by taking a look at the fact that it throws the interrupted exception. Therefore, please simplify the code to avoid the need for a Boolean variable here. You can clean this up a bit. And also, again, don't catch the interrupted exception. Just let that exception percolate up the runtime stack. Down here, if an interrupt occurs, we don't care. Definitely don't be calling acquire uninterruptibly. The whole purpose of having an interruptible acquire method in the simple semaphore class is to let interrupts be percolated back to callers. And there's no need to throw an exception here. And always, always, always make sure to call unlock in a finally block to avoid forgetting to unlock it, as is shown here if an exception occurs. Let's take another look at a problem with acquire. There's no need to check to see if mPermit count is greater than 0 here. There should be a loop using the condition variable above the condition object that will check for that, so there's no need to recheck it here. And please get in the habit of using mPermit count minus minus instead of mPermit count equal mPermit count minus 1. That's not a legitimate Java, C++, C# style idiom for doing decrement. Now let's move into the acquire uninterruptibly call. I'm not sure why there's an infinite loop here that checks while something is not successful, but that's clearly unnecessary and probably quite wrong. Down here, there's no need to check if thread.currentThread.isInterrupted is not equal to true. Just check to see if the flag is set. And for goodness sakes, don't call the acquire uninterruptibly method recursively. That makes no sense. You need to have a loop to do that instead. And that loop needs to call acquire, as we'll see here in a moment. Speaking of which, please refactor this code so it just calls acquire and doesn't have extra checks like if the permit count is greater than 0 and all this other stuff. That's unnecessary. And down here, when an interrupt occurs, you should simply set a Boolean flag and then go back to calling acquire again. Likewise, there's no need to make a call to interrupted here. There's no need to print the stack trace. Those are unnecessary. All you need to do is set this flag. And then on the way out of the method, you should check the flag to see if it was set. And if so, you should interrupt the current thread, which is not being done here. This is returning without doing those steps. Let's take a look at acquire uninterruptibly. Some more problems. Definitely do not acquire the lock here. That's meant to be done only in the acquire call down below, which I omitted, but that should be where that gets done. This logic for handling interrupts is way too complicated and inefficient. Instead, just set a Boolean flag in the catch clause, and then the current thread will be interrupted if that flag is set to true outside of the loop. Down here, there's no need to call unlock. That should be done by the acquire call. And this call to interrupt should be called only if the call, in fact, was interrupted. So check the Boolean flag first and only do it if it was set to true. Let's now move our attention to some problems with release. There's no need to check this, whether the count is less than the permits max. That isn't unnecessary. That's not the semantics of how semaphores work in Java, so we're not following that as well. And please get in the habit of using mPermits count ++ and also put this increment in the try block below. That's where it belongs. Down here, only call a signal if mPermits is greater than 0, and that's because we can start out with a simple semaphore set to an initial value of permits that's less than 0. That's just the way Java semaphores work too. And also make sure that you only increment M permits within the try block and not in the finally block. Doesn't belong in the finally block. And I think this is probably should be permit count, and just to be consistent with what we show above. So make sure you use the right field here and make sure that you increment this inside the try block, not in the finally block. And again, always unlock the lock in the finally block to avoid problems if exceptions are thrown. Assuming that you properly set M permits or M permit count or whatever you call that field to be volatile, there is no need whatsoever to use lock and unlock, so those should be deleted. That's the whole reason to use volatile. Now we're changing our focus to the Palantiri manager, moving away from simple semaphore, and here are some problems I saw there. So unclear why this code is using a synchronized map. That's the whole purpose of using reentrantLock. We don't need a synchronized map, and that is not as efficient in many ways for various reasons we'll talk about later. This code down here uses the 3-parameter version of toMap. It should be using the 2-parameter version instead of the 3-parameter version. And instead of saying Palantir, arrow, Palantir, just use function.identity as the first parameter and use p arrow true as the second parameter. Why there's a call to mmap.size is a mystery. This is why you need to document your code, but it shouldn't be there. And then also, for some strange reason, the various fields are being initialized twice, both above and here. So don't do that, just initialize them one time. We're now going to turn our attention to some problems with the acquire method in the Palantiri manager. First, you don't need to have a try catch block here. Just call those methods. No need to catch the interrupted exception and return it as an error. And then down here, this particular code will fail with a null pointer exception if there's no valid entry in the map. And so please make sure you fix that to handle that case properly. Another problem at acquire, similar to what we saw in the acquire method in the simple semaphore class, never, ever acquire the semaphore or lock the lock in the try portion of a try finally block, but instead always move this type of code to before the try, as we've discussed many times. Down here we have some subtle problems. Don't return a Palantir and then use replace on it, which is what's going on here, but instead either return a map entry or revise the code so there's no need for replace. I don't care which one you do, either one works fine. This code also won't compile since there's the use of a method reference that's improper. Instead, use a lambda expression. That's going to be the right thing to do. And again, down here, don't be calling replace. That's unnecessary. We don't have to go do a hash lookup again, since we've already found the entry that we know that we want to return. Down here, please make sure that you always unlock the lock, even if the Palantir is null. This code is overly cautious and incorrectly overly cautious, so you always want to unlock the lock no matter what. Let's take another look at a problem with acquire. You can refactor this code so it uses the set value method on map entry as a lambda expression in order to simplify the map behavior. Don't call get value in the filter, call set value as a lambda expression, and then you can greatly simplify the map call to just return the key that corresponds to the map entry that was filtered out properly here. Now let's turn our attention to some problems with release. So there's no need to have a catch clause here in release the way we've done it here. And there's also the wrong check. You need to check whether is replaced equals Boolean false, and only in that case do you want to go ahead and release the semaphore. Otherwise, you want to throw an exception because there were some problems with the way the implementation worked. Here's another problem. I don't know what this code is trying to do, but it's trying to make calls that are not thread safe because these calls are being made outside of any lock that's been acquired. In fact, there's no lock being acquired here at all. So this code is, I'm not quite sure why it's here, but it shouldn't be here even if it's the right code at some level. I don't think it's the right code either. Always check for null in release before you do anything else and throw the illegal argument exception in that case. Please don't be calling contains key since it's unnecessary. And also don't be calling is null here. That belongs first. It belongs before the lock is acquired. We need to acquire the lock before we check. We need to check to see if it's null and bail out with an exception before we acquire the lock. Down here, this call to replace isn't quite efficient or isn't quite effective enough. You need to call replace and stash the value in a Boolean with a capital B local variable, and then you'll use that below to do the right thing. So as you can see down here, you only want to call release on the semaphore when replace or put, if you happen to use put, which is also perfectly legitimate, return the appropriate value. And that value should be Boolean.false. So only release in that case. And if you don't get a Boolean false back, then you need to throw the illegal argument exception. So that is basically the walkthrough of the mistakes that I saw when I analyzed the submissions for assignment 2B. If you have any questions, of course, please don't hesitate to ask them in class or post them on Piazza.